Hi, I'm Tomer Itan from Dell Technologies. In this demonstration video, I'll be showing the Dell Virtual Storage Integrator 10 for VMware vSphere client features for PowerStore and how it can help VMware and storage administrators manage their PowerStore clusters. Dell VSI is a plugin that extends the VMware vSphere client, allowing users of the vSphere client to perform Dell storage management tasks within the same tool they use to manage their VMware virtualized environments. VSI enables administrators to view, manage, and optimize the storage directly from the vSphere client. The new version of the plugin can be downloaded from the Dell support site as an OVA file. Once deployed, all you need to do is refresh the browser and then you can start using it. For the purpose of this demo, I'm using vSphere 7 Update Tree with multiple ESXi hosts and clusters. From the vSphere client, I click on the Dell EMC VSI icon, which takes me to the main dashboard where I can find some useful information about my environment. I go to the storage system page and then click on the plus sign to add a new storage array. From the drop-down menu, I select PowerStore and specify the IP address or hostname of my PowerStore cluster, username, and password. Here, we can enable SSL and import the PowerStore certificate. Next, we can provide access to the vSphere users and groups to manage the PowerStore array from the VSI plugin itself. Next, we register the VASA provider automatically in order to be able to create virtual volumes and connect them to the vSphere environment. The host screen allows us to register our ESXi hosts directly from the VSI plugin as hosts in PowerStore, whether they are connected via FC, iSCSI, and NVMe protocol, which has been added to the latest release. Next, I click Finish to add the PowerStore array. In this release, we've added a lot of improvements to the monitoring views so that you can get all the useful information directly from the vSphere client. Capacity and performance monitoring are available for clusters and VMFS data stores as well. By clicking on one of the registered arrays, you can see the summary with all the array's information. On parity with PowerStore Manager, the capacity view shows the physical and logical used capacity on the array, as well as data saving statistics and top consumers in the vCenter. If you switch to the logical use tab, you can see exactly how much capacity is consumed by VMware. These widgets show current and historical metrics and automatically refresh. In the performance view, we can see the current and historical IOPS, latency, and bandwidth metrics of the PowerStore array. In the host view, we have a list of all the ESXi hosts which are registered in PowerStore. We can see the host name, initiator, number of mapped volumes, and if the host is aligned with the array's specific best practices. Another important feature I would like to show you is Apply Best Practices option. This feature allows us to easily apply all best practices on a single host or a cluster to maximize the performance. I click on one of the clusters and highlight the Dell EMC VSI actions, and then I click Apply Host Best Practices. The wizard scans the hosts in order to detect which settings are set correctly and which are not, and allows me to pick and choose which settings to apply according to the storage array connected to my vSphere cluster. I can easily select all of them and apply the best practices on all the hosts in the clusters. For example, if I try this on a single host, it shows items with yellow exclamation points for settings that still need to be remediated. Now that the hosts are registered and the best practices are applied, let's continue with some day-to-day operations. I navigate to the Host and Cluster tab and then right-click on my cluster and go to the Dell EMC VSI plugin actions. From this drop-down menu, I select Create Data Store. When the wizard opens, I can choose between multiple data store types, VMFS, NFS, or vVol data stores. When creating a VMFS data store, I can select the versions and also to choose to create a single or multiple data stores. I click Next here and I can give it a name. Next, I select my storage array. I can see also the capacity information for each array I manage via the plugin. Here, I set the host mapping to the new data stores. On this screen, I specify the capacity. In this case, I want it to be 2 terabytes. I can also select the performance policy, the protection policy, and the space reclamation policy. Then, I click Next and Finish. Within a few seconds, new volumes are created at the array level, mapped to the relevant E6 hosts in the cluster, and formatted with VMFS 6 file system. Once the new data store is ready, I can select it and navigate to the Monitor tab, and then click on the Dell EMC Storage tab. From this screen, I can view general information about the data store capacity and DRR. In order to increase the data store size, I simply type the desired size. So for example, I want to increase the data store size from 6 terabytes to 8 terabytes. I type the new value and click Save. In the background, the array extends the volume and then the host extends the data store to the new size. If you look at the data store summary view now, you can see the new size. The VSI plugin also supports on-demand space reclamation, as known as ANMAP, of VMFS 5 and VMFS 6 data stores, in case you choose to disable automatic space reclamation. This operation allows us to free up the dead space which is still occupied at the storage array level after virtual machine's deletion or migration, and saves a lot of space. By clicking on the performance view, we can get both live and historical information on the volume performance, including latency, IOPS, bandwidth, IO size, and queue depth. Under the Configure tab, we can perform additional useful operations, such as hosts mapping and snapshot creation of that data store. During the array registration, we have the option to register the VASA provider. This allows us to create vVol data stores as well. Very similar to the VMFS data store creation, I navigate to the Host and Cluster tab and then right-click on my cluster and go to the Dell EMC VSI plugin actions. From the drop-down menu, I select Create Data Store and then select vVol block. I specify the name and the storage array I want to create this vVol from. I can also enable quota to limit the vVol size. Then I click Finish to complete the task. Within a few seconds, the virtual volume data store is created and accessible to all the E6 hosts in the cluster. Another useful feature is creating RDM disks via the VSI plugin. In order to do so, we navigate to the virtual machine and click on the Dell EMC VSI tab. Here, we click on Create RDM. Then, we can specify the RDM settings and then select the PowerStore array. Next, we set the size and the performance and protection policies. We click Next to review the settings and Finish to complete the task. In the background, you can see tasks of volume creation and volume attachments. The same way, we can delete RDM disks directly from the vSphere client. This removes and deletes the RDM from the virtual machine, as well as the LAN from the storage array. VSI 9.1 introduces PowerStore VM level restore from Snapshot. As you can see, I have a Windows SQL virtual machine running. By navigating to the Configure view and selecting the VSI tab, we can see the data store this VM is running on. If I click on it and navigate to the Snapshots view, I can change the data store protection policy, which is mapped to a snapshot scheduler, and I can also create a manual snapshot. It is possible to set a retention policy to automatically delete the snapshots after a while. Now, let's assume that something really bad happened to our virtual machine. For example, a ransom attack. With VSI, we don't need to worry at all. Within a few seconds, we can restore the virtual machine from the snapshot we manually created or one of the scheduled snapshots directly from the vSphere client. I navigate to the Host and Cluster tab and then right-click on my VM and go to the Dell EMC VSI plugin actions. From this drop-down menu, I select Restore VM and then the relevant point in time and click Restore. During the process, a volume is created from the snapshot and mapped to the relevant ESXi host. The existing virtual machine is powered off and deleted from the data store. Next, the VSI plugin registers the virtual machines from the snapshot data store and storage remotion it to the original data store. Then, it renames it and unmount and deletes the snapshot volume. This allows us to easily and quickly recover our virtual machines directly from the storage snapshots and back to normal operation within a few seconds. As you can see now, the SQL virtual machine is up and running again. VSI 9.0 introduces PowerStore NVMe fiber channel support, includes host management, data store provisioning, clone, refresh, restore, and more. VSI 9.1 introduces PowerStore NVMe over TCP support, allowing customers to view NVMe fabrics information, viewing hosts, adding hosts, data store provisioning, creation of thin clones, etc. I navigate to one of my ESX hosts and click on the VM kernel adapters. This host has an NVMe over TCP VM kernel adapter enabled. In addition, I created a virtual NVMe over TCP adapter and registered my PowerStore ports. I navigate to the VSI storage system views. This screen allows us to register our ESXi hosts directly from the VSI plugin as hosts in PowerStore storage array, whether they are connected via FC, iSCSI, or NVMe protocol. I click on the plus icon and change the protocol type to NVMe, and then select my ESXi host and click Add. Now that the host is registered at the array level, I can create NVMe over TCP data stores using the VSI plugin. I navigate to the Hosts and Cluster tab and then right-click on my host and go to the Dell EMC VSI plugin actions. From this drop-down menu, I select Create Data Store. When the wizard opens, I can choose between multiple data store types. I click Next here and then I can give it a name and select my storage array. I can also see the capacity information for each storage array I manage via the plugin. Here, I set the host mapping to the new data store. I switch it to NVMe and then select my NVMe over TCP host. On this screen, I specify the capacity. In this case, I want it to be 2 TB in size. I can also select the performance policy, protection policy, and space reclamation policy, which is also supported with NVMe protocol. Within a few seconds, new volume is being created at the array level, mapped to the relevant ESXi host via NVMe over TCP protocol, and then formatted as VMFS 6. If I go to the Devices tab, we can confirm that the volume is connected using NVMe over TCP. Similar to iSCSI and FC data stores, we can get the same performance and capacity views for NVMe over TCP data stores and perform the same operation, such as manual unmap, volume extend, etc. Unlike SCSI protocol, with NVMe, there's no need for rescans. NVMe has async events, which allows the array to instantly inform the host of a new storage, resize, etc. The VSI plugin is based on a lightweight Photon OS operating system. When new security patches are available for installation, you receive an alert about it. In order to apply the patches, all you have to do is navigate to the VSI Updates view and then click Update. A volume group is a logical container for a group of volumes, which provides a single point of management for multiple storage resources that work together as a unit for consistency and easier management. As you can see, I registered my ESXi hosts with my Firestore cluster using the VSI plugin and created two VMFS data stores. By navigating to Firestore Manager, we can see the four ESXi hosts registered and mapped to the data stores. We can also see the two VMFS volumes under the Volumes tab. At this stage, there are no volume groups configured in the system. We navigate back to the vSphere client and click on the VSI icon. Then, we select the Firestore cluster and click on the volume group icon. Here, we click on the plus button. Now, we provide a name and assign a protection policy. To ensure consistency protection across all the members of the volume group, we select the Apply Write Order Consistency to all volumes in this volume group. Next, we select the data stores we want to add to the group. We can filter them by the cluster for simplicity. Now, we click Create to complete the task. By navigating to Firestore Manager, we can see that a new volume group has been created successfully. If we click on it and go to the Members view, we can see the two VMFS data stores that I selected. Metro Volume is a high availability and data mobility feature for Firestore Storage and VMware vSphere. It provides active-active data access to Metro volumes for proactive use cases between Firestore clusters. The new VSI plugin allows us to configure and manage it directly from the vSphere client. As you can see, my ESXi hosts are configured as Metro nodes and mapped to both Firestore replicated clusters. We can modify the host connectivity directly from here. We can set it back to local or change the remote cluster. Now, let's create a new VMFS data stores using the VSI plugin. I'm right-clicking on my cluster and selecting the Create Data Store option from the Dell VSI drop-down menu. Here, I'm providing it with a name and creating a single VMFS6 data store and mapping it to my cluster. By navigating to Firestore Manager, we can confirm that a new volume has been created and mapped to all the ESXi hosts in that cluster. Now, let's apply the Metro configuration on that data store from the VSI plugin. We click on a data store and navigate to Configure and select the VSI plugin page. Under the Protection section, we click on Configure Metro. We select the remote system and make sure the data store will be mapped to all the ESXi hosts in the cluster, and then we click Configure. In Firestore Manager, we can see that the volume is now Metro protected, and the volume is running as active-active in both clusters. If we switch to the remote cluster, we can see that the Metro volume has been created, synchronized, and mapped to the same ESXi hosts. Apart from the SRM support for PowerStore, we've also added our unique point-in-time integration with the VMware VSI plugin. This feature allows us to specify a specific point in time to test or failover to when using SRM. Let's say you have a logical data corruption or a malware infection. It's not enough to run a failover to the DR site. You want to actually failover to a specific point in time before the data corruption. In the vSphere client, we select the Firestore cluster in the VSI plugin view and click on the SRM recovery points under the Protection tab. By default, SRM uses the most recent replicated snapshot for test or failover. This unique integration allows us to select a previous point in time for each SRM protection group and also to select different snapshots for each protection group. If needed, we can always clear the selection or choose different ones based on our expiration policy rules. Another cool feature we've added in this release is Firestore Application Rules Management using the VSI plugin. We select our Firestore cluster in the VSI plugin view in the vSphere client and click on the Application Rules tab under the Protection tab. Here, we can see a list of all the existing replication rules, including their attributes such as RPO, alert threshold, destination array, and attached policies. To create a new rule, we click on the plus icon. Here, we provide it with a name and select an existing destination array or set up a new one if needed. To add a new remote system, we click on the Setup New button and provide the array ID, select the network latency from the drop-down menu, provide the username and the password, and then click Add. We can continue with the replication rules creation for the new destination that we've just added. In this release, we've added more appliance and node performance monitoring views directly from the vSphere client. First, we navigate to the PowerStore cluster in the VSI plugin view and click on the Performance tab. By selecting the appliance, we can filter the view by a specific node or the whole appliance. This provides us with a detailed performance information for each and every node in the system. The new views provide us both live and historical metrics for bandwidth, IOPS, latency, memory and CPU utilization for apps on appliance, and the IO size used by our applications, and also the queue depth. We can change the time range and zoom in and out to get all the required information we need about our PowerStore clusters and their workloads, directly from the vSphere client. I really hope you find this demo useful, and thank you very much for watching.